Okay guys, welcome back to my channel. So now we are still on mathematical induction under divisibility, but we want to do the ZIMSEC June 2025 paper 1 question which had 10 points. That's a lot and we don't need to lose this. So the question reads, prove by induction that 5 to the 2n plus 5 all over 5 is divisible by 3 for all integer values of n. So just out of interest, do you know this question can also be rewritten as 5 to the 2n divided by 5 to the first power plus 5 over 5, which can be rewritten as 5 to the 2n minus 1 from the rules of indices plus 1. So in other words, they can also ask you that, prove by induction that 5 to the 2n minus 1 plus 1 is divisible by 3 for all integer values of n. Okay, so now coming back to the question where we want to prove that 5 to the 2n plus 5 all over 5 here is divisible by 3 for all integer values of n. So our first step is to prove when n is equal to 1. So when n equal to 1. So when n equal to 1 here, we are going to say 5 to the 2n plus 5 over 5 is equal to 5 to the 2 times 1 plus 5 over 5, which is equal to 10 over 5. Sorry, not 10, but this is 25 plus 5, which is 30 over 5, which is equal to 6. And in this case, 6 is 3 times 2. Right. So remember, we are trying to show that it is divisible by 3. So 6 in this case is also a multiple of 3. So it's true. So which is divisible by 3. Therefore, the statement is true for n equal to 1. Right. So once we have identified that the statement is true for n is equal to 1, we then move on to the inductive hypothesis, which is our assumption stage. So when, it's assuming, I'm sorry. So assuming true, so we always assume true. So assuming true for n equal to k, right? So when we assume true for n is equal to k, we are going to get 5 to the 2k plus 5 over 5 equal to, you just have to put your 3 times something, remember our constant. Then you state the result, then for n equal to k plus 1. So you're going to state the result. When you plug in k plus 1 for n, you must get another constant as well. Right. So after this, we are going to move on to the proof stage. So on the proof stage, start by writing this. So in this case, you can also say this. You can also say 5. You can also say 5 to the 2k from the assumption. If you multiply both sides by 5, I'll get 15a. So is equal to 15a minus 5. Right. You can use this. Remember, we always use the assumption stage as well to help us to prove. Right. So from there, on the proof stage here, you can say 5 to the 2 k plus 1 plus 5 over 5 equal to 3b. Right. So in this case, what we need to do is to play around with the left-hand side. So my left-hand side here. So on the left-hand side, we are going to have 5 to the 2k plus 2 plus 5 all over 5, which is equal to, from the roots of indices, it's 5 to the 2k times 5 to the 2 plus 5 over 5, which is just 25 here, open parenthesis. Then 5 to the 2k, remember 5 to the 2k was 15a minus 5 here, right? Then plus 5 all over 5. So in this case, you can divide by 5. So if we divide, we are going to get 5 bracket 15a minus 5 plus 5, right? Which is equal to, sorry, this is 1, I'm sorry. I am so sorry. This is 1. So which is equal to 5, 15a, then here minus 25 plus 1, which is equal to 5 or 15a minus 24. Then now we can take out 3. And here we remain with 5 times 3, it's 5a minus 8, right? Which is slightly equal to 3b, where b is equal to 25a minus 8, which is true for n equal to k plus 1. So we give a conclusion. Therefore, the statement is true for n equal to k plus 1. Then now we give our overall conclusion. Since the statement is true for n equal to 1, n equal to k, and n equal to k plus 1. Therefore, by induction, right? Therefore, by induction, the statement is true, or it holds, or simply the statement is divisible by 3 for all integer values of n. Then we are done. So just to go back, remember for mathematical induction by divisibility, right? The first step here is the base case where we are proving for n equal to 1. We move on to the inductive hypothesis, which is our assumption stage. Then from there, I have this thesis and the proof stage. This is just the inductive step, right? Then you give your overall conclusion. But remember, for the proof stage and the base case, you have to give a conclusion in each case, right? Maths ziri kuzochipa. So guys, if you haven't subscribed to my channel on YouTube, on TikTok, please go ahead and do so. Okay, we'll meet on the next segment.